You may think you need to burn a lot of money on a big telescope to take photos like this.
Think again, because I took that photo using this very exact setup, a simple tripod and a really cheap camera and lens combo that cost about $200. And I'm going to show you every step I did to do that.
2.5 million light years away is the Andromeda Galaxy, the most distant object visible to the naked eye. This galaxy is a classic example of a spiral galaxy. Here we can see the companion galaxies. Now this is quite large in the sky and spans the width of about 6 full moons. Before we continue, do you like astrophotography tutorials and want to be featured here on my YouTube channel? If yes, feel free to tag my Instagram account on your posts. I would love to take a look and see how my videos are helping others. Let's get back to the video and first talk about the gear.
The gear I use for this project is a simple tripod plus a Canon Rebel T6 paired with a 50mm lens, or the nifty 50 as we call it. I like to use this because it's a fast lens. Well, fast in the sense that it has a large maximum aperture or a low f-stop, and coming in at about $60 used, this lens is a great budget lens for astrophotography, which is why I like to call it the thrifty 50. Now you don't have to use a DSLR, you can use a mirrorless, and you don't have to use the nifty 50 lens.
In short, you'll need a lens with a low f-stop, a digital camera, and a tripod. Let's talk next about the location.
Remember how I said the Andromeda Galaxy is really bright? That's the best part, because unlike other deep sky objects, you don't have to go to a dark sky site to image it. If you can, it's ideal, but not necessary. In fact, I shot this photo in Bortle Class 5 skies near my house.
To figure out what the light pollution looks like in your area, go to lightpollutionmap.app. Here you'll find a website where you can see a map showing areas of the greatest light pollution all the way down to the areas of the lowest light pollution. To figure out what the light pollution looks like in your area, go to the top right corner and click the search icon. Here you'll enter your address and you'll be able to see the specifics on the light pollution in your area. Now unfortunately, light pollution does change over time, but one of the nice features about this particular website is in addition to seeing the light pollution, you'll also be able to see the light pollution trend over time. You'll also want to avoid other sources of light pollution, such as street lamps and security lights, as these can wreak havoc on your images. Let's talk next about the time. But first,
where exactly is the Andromeda Galaxy in the night sky?
In the northern sky is a constellation called Cassiopeia. It looks like a W or an M. To find Andromeda, start with this bright star here, Shedar, and use the other 2 stars to draw an arrow. This will point in the general direction of the Andromeda Galaxy. Both of these rotate counterclockwise around the North Star Polaris. In August, as the evening begins, you will see these in the northeastern sky to the right of Polaris. As fall progresses into winter and then into spring, Cassiopeia and the Andromeda Galaxy will rotate to the other side of Polaris in the northwestern sky, which means the Andromeda Galaxy is visible many months during the year in the mid-northern latitudes. You just might have to wake up really early to see it. In the mid-northern latitudes, Polaris is higher in the sky, so the Andromeda Galaxy will be as well. However, in the southern latitudes, Polaris is not visible, so the Andromeda Galaxy will be significantly lower in the sky. Whether you're in the northern or southern hemisphere, August through November is the best time to photograph this. You'll also want to wait for a new moon, which is when the moon is least illuminated. Also try to photograph the galaxy when it is at its highest in the night sky. Let's talk next about your camera settings. First, switch your camera to manual mode, then turn on manual focus. To calculate the exposure length, we'll use the rule of 500, where we take 500 and divide it by 2 variables. The first is called crop factor. That measures the size of your camera sensor. For full frame cameras, it'll be 1, and for smaller sensor cameras like your crop sensors, it will be greater than 1. In my case, it was 1.6. Then we'll look at focal length. In my case, it's a 50mm lens, so it will be 50. I then take 500 divided by the product of 1.6 times 50, that equals about 6.25 seconds. These exposures could have been longer. The goal of all of this is to compensate for the rotation of the Earth and avoid star trails in your images. The exposure on the left is too long, the stars are trailing. The exposure on the right, the stars are pinpoint, and that's what we're after. Next, you'll want to open the aperture as wide as possible. As far as the ISO, I chose 3200. You may need to adjust this for light pollution. You may also want a 2-second delay on your camera so your hand is off it while it's shooting. I also decided to shoot in RAW and large JPEG. RAW images will be the ones we use for our final photo, and JPEG can be used for the computer preview. This example of a single photo is a bit underwhelming, but don't worry, we'll turn it into a masterpiece soon enough. Next, let's talk about imaging.
Because we're shooting with such a wide field lens and because Cassiopeia is such a bright constellation, it won't be hard for us to find it in a live view of our camera, even under light polluted skies.
The first thing you'll want to do is use the digital zoom to zoom in on a bright star. This is how we'll achieve focus. Once you're zoomed in, push your camera lens all the way to infinity and then slightly back it off. The goal is to have the star be the smallest white dot. Purple fringe is okay, that's expected with cheap lenses. Then you'll want to zoom out and reframe Cassiopeia to where we can get Andromeda Galaxy in frame. Remember, move the direction of the imaginary arrow to find the Andromeda Galaxy. Here's the arrow, and here is where we can expect to see the Andromeda Galaxy. Let's take a test shot and see what happens. Here's Cassiopeia on the right, and on the left, we can see the core of the Andromeda Galaxy. Next, center your camera on the Andromeda Galaxy or about to where you think it is. This may take several tries and require several test shots. Eventually, you'll want it looking like this. After this, you'll take 250 light frames, or photos. Now you will need to recenter your camera every 10 to 15 images because of the rotation of the Earth. An easy way to do this is use the rectangle to reframe on a bright star. As long as you keep that reference star centered between sets, you'll be good. Now your camera sensor can be pretty noisy. Wait, what? That's right, I don't have to tell you that our technology today is sometimes less than reliable and not perfect. Here's a simple process of an image I captured, and even just a little bit of it reveals noise and artifacts, things like vignetting, noise, and hot pixels. We can compensate for these noise and artifacts by taking 3 calibration frames. Dark frames, which capture the thermal noise from the sensor, bias frames, which capture the sensor readout noise, and flat frames, which capture any vignetting or dust present. Still confused? Think of it like this. You finally made it to that scenic overlook, and just as you expected, it happens.
Main character volumes, W height, real for real.
In our astrophotography images, we expect to see noise and artifacts. Just like when you're at that scenic overlook, you expect to see these guys. Calibration frames can help to isolate and identify noise and artifacts. In short, the calibration frames allow us to account for the unwanted distractions in our images. Now it may sound a little like cheating, but it's not. Even NASA uses calibration frames. So let's talk about how to take calibration frames. Take these after your actual photos, so that the dark frames are taken at the same temperature as the photos, and so you can keep the same focus. For the dark frames, you'll first want to replace the lens cap, turn off the shutter delay, and then shoot. You'll want to take about 50 of these. For the bias frames, you'll set the exposure length to the shortest possible with the lens cap still on and shoot about 50 photos. The flat frames are a bit more involved. You'll need first a white t-shirt or paper sheet and an evenly lit background. What do I mean by that? No, I don't mean that. I mean an evenly lit sky or light source, such as the dusk sky or a ceiling. I used my lights here to evenly light the ceiling, and it worked best for me. First, you'll remove your lens cap and then switch to AV mode. Then, you'll point the camera vertically at that light source and place the t-shirt or paper sheet over the lens, making sure it's flat. Then you'll take the photos. Let's rewind that real quick. Take a look at the histogram. It's about 50% exposed, and that is what you want to aim for. Take 30 of these flat frames. Here is a quick review of the details for each of these. Please feel free to stop this video and take a screenshot at this time so it's easier for you to remember. After you have those photos, I'd recommend taking them off your camera, putting them in your computer, and organizing them into folders. It makes things a lot easier. Let's talk next about stacking. Now you may be doing the math and be asking yourself, why on earth did I take all those photos? I mean, isn't one photo good enough? Not quite. See, space photos have a secret. Even though they're masquerading as one, they're really a bunch of photos that have been combined. They've been combined through a process called stacking. Get it? Where you take the individual photos, integrate them together, and then you get a finished image. We use the stars in each of the photos to align the images. The noise is fairly random across the photos, while the signal is fairly consistent. So as we integrate more individual photos into our final image, we increase what is called the signal-to-noise ratio and get a much cleaner image. What we will do is integrate the light frames, the dark frames, the flat frames, and the bias frames using a free online software called Deep Sky Stacker. When you open Deep Sky Stacker, it will look like this. The first thing we'll do is upload our light frames, and like I said, organizing ahead of time really helps. Go ahead and go to the lights folder and make sure you're selecting the raw files. Go ahead and select all those files and then click open. Now even though we've imported these, we need to check all of the boxes. So instead of going down one at a time, you can select all the files that have been imported, and after doing so, right click and then click check. Now they are all imported. Next, we'll import our dark frames using the same approach. In this case, you won't need to check these boxes, they're already imported. Make sure again that you are using the raw files. After the dark files, we'll then go to the flat files. We'll do the same thing again, making sure we have the raw files, and then we'll open. Lastly, we're going to import the bias files, select them all, and then click open. We now have each of the light frames, dark frames, flat frames, and bias frames imported. The next thing we'll do is adjust the register settings. I'd recommend setting this to the best 95% photos. Next, we'll want to make sure we have enough stars in our images so they can align properly. We can see we've got quite a number. We can actually slide that slider down so we don't have quite as many. Let's run it again, and after doing so, we see that we've got a few hundred. That should be good enough. After that, we'll go to the recommended settings, and as a general rule, the recommended settings in blue beneath red usually yield good results. For the stacking setting, there are two options. I used the Sigma clipping method that worked best for me in my case. After that, you'll click OK, and then click OK again. All of our light frames have been uploaded for a total of about 12 minutes of exposure, and we have all of our calibration frames as well. Go ahead and click OK. Depending on the computer you have, it may take anywhere from 15 to 45 minutes. Let's go ahead and jump ahead. This is our final output image, and up here in the top left-hand corner, you can see the location of your file. Now that you have your stacked image, we can move on to the final part of this tutorial, processing. In this case, I'll be using Photoshop, and you can get a free 7-day trial online. Now, if you have an aversion to free trials and don't want to put in credit card information, then Photopea is a good alternative. In addition to having a similar interface, it has many of the same functionalities as you'll find in Photoshop. But like I said, we're going to do ours in Photoshop. And the first thing we'll do is save our file as a PSD or Photoshop file. The next step is we'll go to Image, down to Mode, and then 16-bit channel. We're going to change the mode using the exposure gamma settings and change it to 16-bit mode. Click OK. And now what we're going to do next is duplicate the layer. You can use the hotkeys Ctrl-J to do this. I plan on renaming all of my layers so that you can have a simple reference to screenshot when you're doing your processing. The next thing we're going to do is we need to level out this background so it's more gray. So we'll do Ctrl-L to do a levels adjust. Click the middle eyedropper and then click somewhere in the middle to try to get a nice background that matches. Once you've done that, you'll click OK. Go ahead and do Ctrl-L again, and then we're going to grab the leftmost slider and pull it towards the histogram. Usually you wouldn't want to clip off this part, but that's just an artifact from the stacking, and that's okay. We'll address that later. Pull it a little bit more towards the center and then click OK. Now to address those artifacts, we're going to crop the image in. So grab the crop tool and pull the sides in slightly to get rid of that weird framing artifact. Now we can do Ctrl-L again, and this time you'll see that there's no artifacts in the histogram. So go ahead and pull the left slider over and then take the middle one and pull it towards the histogram. We're going to do this a few more times, and as we're doing this, you'll notice that we are revealing more detail in the galaxy right here, but we're also keeping the background a little bit balanced. We'll go ahead and do this one more time. Now what you start to notice is some of the background changes as we're doing this. So what we'll need to do is go in and grab the middle eyedropper again to set another gray point. The other thing that we're going to do is we can actually adjust the individual channels. We can go through the red, green, and blue and try to get them as balanced as possible so we've got a nice flat background. After this, create a new layer from the visible by holding Ctrl-Shift-Alt-E, which is something we'll do throughout this process. Then we will continue to do a few more levels adjusts. Open up levels again, grab the left slider and pull it towards the center, click OK, open up levels again. Make sure you do not pull it into the histogram. This is called clipping the data, and it's not good. So pull it right up to the edge, and then click OK. Open up levels again, and then pull the center one towards the histogram as well. Now we're really starting to see the galaxy pop out in our image, which is great. We're going to do one more levels adjust. And that's looking pretty good in the center here with the galaxy. We're going to create a new layer from the visible. Next, we'll do what's called a curves adjust. So hold Control M, and the curves window will pop up. This shows the histogram from the black point all the way to the white point. And what we're going to do is stretch the data. So we're going to click somewhere on the histogram, right about here, and we can pull that up slightly and pull the middle part of it down. This is going to allow us to have more contrast and reveal more detail in the galaxy. We don't want to do too much because we're starting to get this nasty gradient over here, so we can pull this back just slightly and then pull the part down a little bit too. It may take a little bit of playing with it, but do your best to get something that looks just about like this. Click OK. Now, as you can see, we have this nasty gradient. So after creating another new layer from visible, what we are going to do is use the linear gradient tool to get rid of that. First, make sure you save that project before you lose it. Very important. Learned this one the hard way. And then we're going to address the gradient. So go to Filter, Camera Raw Filter, and what we're going to do first is zoom out a little bit farther to something that's maybe about 12%. Here you can see the gradient is pretty bad. So we're going to go over to this circle icon and create a new linear gradient. We'll go to the side of the photo that has the gradient, click in the area that has the most gradient, and then pull towards the area that does not. Now you can redirect the center and vector of the gradient, but this looks pretty good. Then when you go back to the right-hand side, you can toggle the amounts of the exposure, the contrast, as well as any number of other values to make sure it meshes in well. After zooming in, we can see that the gradient's looking a lot better. If we go down, we can also adjust the tint and the temperature. But I'm pretty happy with the contrast and exposure that we've landed on, and I think this is looking pretty good. You can really see how this simple process took care of much of the gradient. And as we zoom in on the galaxy, we can really start to see some of the dust lanes popping. You can even see some of the young blue stars on the outer edges. So we'll create another new layer from visible. And after we've done that, we're going to do yet another curves adjust. When the curves window is open, you can actually click with the eyedropper tool somewhere in the image, and that value will plot itself on the chart. This makes it easy for adjusting just the areas you want to focus on. We can zoom in on the galaxy, and you really start to see the details popping even more with that simple curve stretch. Next, we're going to do a new layer from visible, and then after that, we're going to address these nasty blue halos around the stars that were caused by our cheap lens. Go up to Filter, Camera Raw Filter, and then go over here on the right-hand side to Optics. Here we can set the purple amount and purple hue we're choosing to defringe. Don't pull it too far into the blue, or else you'll remove the blue stars from the galaxy. So really focus on adjusting the purple amount to get to where you want to go. You might have to play around with it, but that's okay. Do some guessing and checking to make sure that the blue stars in the galaxy are remained. After you click OK, you can really start to see the big difference that you made in the stars and how they look a lot better than they did before. After this, we'll do another new layer from visible, and then another levels adjust. We can see the background is starting to look a little bit green up here, so we're going to go to the green channel and slightly adjust some of the sliders for that. We can pull the left-hand one in, but you don't want to go too far, it'll turn too red. Next, we'll go to the red channel and we'll adjust that one slightly as well. And then we can click OK. We'll do another levels adjust, and this time we'll focus on the blue channel and make sure that we don't move those sliders too much. That looks pretty good. Before we continue, go up to File, Save As, and then grab the drop down to make sure that the TIFF is selected. We need to save this file as a TIFF file for StarNet. I'm naming it something including StarNet so that I can make sure I know where it's at. Once it's saved, click OK, and then click OK again. What is StarNet, you may ask? It's a free program to remove stars from your photo. So you can take a photo like this and turn it into one like this. This is what the website looks like, and if you scroll all the way to the bottom, you can see the download for Windows. Now once you've downloaded it, you'll have to make sure you right-click it and extract all the files. Now what I'm going to do is go back to that TIFF file I saved and actually cut it and paste it into the extracted file folder. Then I'm going to go up to the StarNet GUI and double-click it. This will open the interface for StarNet. I can then browse to the file that I just moved to the folder. Here's even a test file they provide, and then I can click on that file. Once I've opened that, I then need to make sure I change the output file name. I'm going to change it to something called StarNet Output, and then I'm going to click Run. Now this will take some time, but let's use some movie magic again. Now that it's finished, we can see the output file, and we're going to open that in a separate Photoshop project. The first thing we'll do when we open it in a project is zoom in and look at that detail that we can see now that we've removed the stars. So the first thing we're going to do is we're going to actually remove a lot of these artifacts from the leftover stars that were not removed. We're going to use a spot healing brush tool on the left-hand side. As far as the brush tool settings, I used something medium, and you want to make sure you also have a low percentage hardness for the brush. The normal mode also works pretty well, and all you're going to do is just click on each of the stars and remove them. This may take some time. Let's use that movie magic again. Now that we're done, we're going to create a new layer from visible, and then again we'll create another new layer from the visible. Next we'll do a curves adjust, and we're going to do a slight adjustment, again stretching the data a little bit more. As we're doing that, we want to make sure we're not blowing out the core of the galaxy, so we want to be careful with those highlights. Click OK, and things are looking a lot better. We'll do another levels adjust to make sure that things are balanced in the background, going through each channel as needed to where we can get something that's nice and neutral. We're going to create another new layer from the visible, and then we're going to adjust the vibrance and saturation for this particular layer. So grab that saturation slider and pull it up, but not too much. If we zoom in, we can start to see some of the detail in the outer edges and some of that blue coming through nicely. After we've created another new layer, we're going to do another levels adjust. We're going to set the gray point again by clicking somewhere in the image and then clicking OK. Now one thing we want to focus on is a selected color range for focused saturation. So we'll click Select, Color Range, and then we'll use the eyedropper to click somewhere in the galaxy. You can adjust the fuzziness to change the amount that's being selected, and then click OK. We've primarily selected the outer edges, and then we'll click Hue Saturation again to bump up that saturation even more on the outer edges of the galaxy. Things are looking pretty good, and after we create another new layer, we'll do yet another levels adjust. Now as we continue to brighten this image with these level adjusts, we want to make sure that things are remaining balanced. So we can go into these individual channels again and make sure that things have a neutral background. This is a constant iterative process that you'll need to keep checking on throughout your process. If we zoom in on the galaxy now, we can see things are looking really good both in the core and the outer edges. What we're going to do now is Control-C and Control-V this starless image onto our main project. Here you can see the difference in terms of the amount of galaxy we've revealed compared to how it originally looked. After renaming this layer, I'm actually going to copy the layer that had the stars and place it on top of the one that does not have the stars. Then I'm going to adjust the opacity of the star layer on top to 80%. I'm then going to create a new layer from visible. Now there are many different ways to combine starless and star layers. This is just one really quick option, not necessarily the best, but it can get the job done. Let's do a quick comparison to the way things looked before and the way things looked after. We can see the stars are significantly less bright and they're a little bit smaller as well, which can help our overall process. Zooming back out, we'll turn on all of our layers again, create another new layer, and then we're going to do another curves adjust. Clicking that eyedropper somewhere on the outer edges of the galaxy, and then pulling up to the right. Then we'll click in the dark space down below, and we'll pull down. As we do this, you'll really start to see the difference between the starless and star image. Notice that the stars don't really change at all, but the galaxy is that much more pronounced. This is exactly what we are after. But we also want to make sure that the core of the galaxy is not blown out, and I think we've done a pretty good job here retaining that detail, especially in the dust lanes. After zooming back out and turning on all of our layers, we can see that there's a lot of unused space in this image. Because of the sensitivity of our camera, we can't pick up much of anything else. So what you can do as an option is copy the top layer to a new Photoshop project, and then we're going to crop it in from there. I don't want to crop it in this layer because I don't want to lose the processes I've already worked on. So once we've pasted it into a new project, we'll then use the crop tool to bring it in to just the area of focus, particularly around the galaxy. This will make things significantly easier when we're processing. After this, we'll do another new layer, and then we'll do another levels adjust. Grab that middle eyedropper and click somewhere in the image. Then click OK. After creating another new layer, we're going to adjust the vibrance and saturation yet again for this image. Go ahead and pull that vibrance up a good amount, and then the saturation as well. This is getting some of the details we really want to start to see, especially those blue stars on the outer edges. But we don't want to do too much, so you might have to back it off some. We'll create another new layer. I know you're probably tired of hearing me say that. We'll create another layer, and then we'll do a curves adjust. So by clicking somewhere on the outer edges of the galaxy, and then pulling that up, and then pulling down the left-hand side, we can really start to see the outer edges of this galaxy contrast against the darkness of space. After creating another new layer and naming both of these, you can do an optional brightness adjust. If you feel that the stars and the galaxy in your image are perhaps a little bit too washed out, what you can do is go to Adjustments, Brightness Contrast, and then turn down the brightness just a little bit. You don't have to, I just want to show you all some tools and tricks you can use so that you can develop your own process. When we create a new layer, you can see the difference and how things aren't quite as washed out in the center, which is what we're going for. After creating another new layer, if you zoom in on these stars, you can start to see still some of the blue halo coming back from earlier. To address the saturation of the galaxy without adding to this, we're going to go to Select Color Range, and then we'll click Localized Color Clusters. After that, grab your eyedropper and click somewhere in the center of the galaxy, and adjust the fuzziness to make sure you're selecting just the galaxy in the center. Make sure you pull that range down so it's localized just to the galaxy, and pull the fuzziness up so you get as much of that core as possible. You may have to play with it. Then click OK. Now you can see we've selected just the core of the galaxy, and what we're going to do is another saturation and vibrance adjust for the center of the galaxy. As we pull these up, we can see that color start to come through without affecting the rest of our image. After you create another new layer, we can then do another curves adjust. We're going to click somewhere on the very outskirts of the galaxy, and then click over somewhere in empty space, and pull it even more. Now, doing it way too much can make things really grainy, so just make it subtle. It's a very iterative process, and it takes practice over time. Toggling it on and off shows us yet again how we're bringing out more of the galaxy while managing the brightness of the stars. Now, if we zoom in, we can see those pesky blue halos are back. So what we'll do is we'll create a new layer from Visible, and then we'll go up here to Filter, Camera Raw Filter. We're going to use that same defringe optics tool that we used earlier, but this time, in addition to adjusting purple, I'm going to slide the purple hue over to the left to get into the blue. We'll use an eraser tool to mask out this new layer and make sure we don't remove the color from the galaxy. Now, if we zoom in on the galaxy, you can see how this action actually removed some of the blue color in the stars on the outer edges of the galaxy, especially as we toggle on and off these layers. So what we're going to do to bring this back is use an eraser tool that's a small to medium size, with a very low percentage hardness and a very low percentage opacity, and clicking on the top layer, we're just going to erase the galaxy as it appears. This will remove the part underneath to where we can restore those blue stars and maintain the color. After that, we're going to create another new layer, and then we're going to adjust the vibrance and saturation one last time. After one more layer, I promise it's the last one, we'll do another levels adjust to bring out a nice even background. In this case, I'm going to go to the green channel and pull it to where I see fit. Now, you can repeat these processes again and again and do them in different orders. There is no one exact way to process the image, and there never will be, but these are some of the commonly recurring approaches and techniques that you can use to achieve the final image like I did.
If you liked that video, please consider subscribing. It really helps my channel. And if you have any other ideas for other astro tutorials, let me know in the comments. I would love to hear them. Thank you so much again for watching.